All right, so today we're looking here at graphing in vertex form. We've been focusing on vertex form. Remember, it's another way to interpret a quadratic function. Okay, so we'll be looking at vertex form. It's kind of the easier one. It's easier to graph in vertex form than standard form. So what, why, now, we will learn how to graph a quadratic function. That, of course, is in vertex form. Why? Vertex form is another way to interpret a quadratic function. So the how today, this is how we know if we've accomplished a what. Students will be able to graph the quadratic function, and here it is in vertex form. And again, this exact same equation, this exact same function, this would be this in standard form. Okay, so if you look at it, this one here would be much more challenging to graph than this. Okay, so we're looking at vertex form. So the generic version of vertex form, we have our A value, which tells us whether it opens up or down, also how wide or narrow the parabola will be. And then, of course, we have x minus h plus k here. H and k represent the vertex. Okay, so here we have this function, x minus 3 quantity squared minus 1. Okay, which direction does it open? Well, let's look at the a value. This is the number right here, right in front. See, a value is right in front of the parentheses. There's nothing there. Well, yeah, there is. There's an implied number. There's a positive 1 there. Since it's positive, we know that it's going to open up, and it's going to have normal width because the number is 1. Okay, just like the parent function. The parent function has a value of 1. So we just say that's normal. Okay, so first what we'll do is we'll plot the vertex. Really easy. Remember, opposite of h comma k. So positive 3 comma negative 1. And then the AOS, remember the AOS is right in the middle. So there's 3 comma negative 1. The vertex is right in the middle as well. So the AOS is going to go right through this. Okay, so the AOS is always the x value of the vertex. So it's x equals 3 right there. Okay, it says to find 2 other points. Okay, I mean, technically we could just go ahead and graph it. We know it's normal width, this and that. But you know what? Let's use a little bit of algebra. Okay, let's practice it anyway. It's good for us. And let's graph 2 other points because we're actually going to use the AOS as a mirror. Once we find one, it'll help us find the other. Okay, so I'm choosing the point 2 because what I'm doing is, I'm sorry, the x value 2, because I want something close to my vertex. So my vertex or my AOS is 3. So I could choose 2, I could choose 4, I could choose 1, I could choose 5, just something close to this number 3. I don't want to choose something way over here because that's going to give me a number way up here. So I want to stay close to the vertex. So I'm going to choose 2. Okay, so that means I'm going to plug 2 in because that's going to be my x value. My x value is going to be 2. I just need to know where it is. I'm going to plug it into my function. So here's my function right here. Remember, f of x is just y. So once we plug in 2, which is my x value, it will give me my y value. So 2 minus 3 is negative 1. And then we do negative 1 squared. Remember, we have to do the order of operations. Negative 1 squared is 1. And then 1 minus 1 is 0. So I have 1 point here at 2 comma 0. So I'm going to go ahead and graph that. 2 comma 0 right there. Now remember, this AOS, this invisible line, acts as a mirror. So if I have a point 1 unit away on this side, I will also have another point 1 unit away on that side. Okay, so I will have a point here, but I'm just going to go ahead and choose another point. So I chose 2 for my x value. So now I'm going to choose 1 because I'm just going to stay close to it. So remember, we have the vertex of 3, and I chose a number close to it, which is 2. And then I'm just going to choose 1 and see what happens and see what I get. Okay, and if you wanted to, you could actually plug this into Desmos. This right here, exactly the way it is without the y equals, just 1 minus 3 with parentheses squared minus 1, and it would spit out your answer. Okay, So we got negative 2, and then negative 2 squared is 4, and then 4 minus 1 is 3. So I have a coordinate at 1, 3. So 1, 1, 2, 3 right there. Okay. Now we're actually going to use the mirror. We're going to say, hey, this is 1 unit away, so I should have a point on this side. This is 2 units away, so I should have a point right here on that side. And then we can just draw the parabola through the points, and we have a nice, good-looking parabola. Okay, so let's look at another example. I know maybe this part here, finding the 2 points, might be challenging for you, but hopefully we can at least find the vertex, the AOS, and draw our parabola from there. Okay, so imagine here's the parent function. This is y equals x squared. Okay, now what's happening here? Well, this is moving it to the right 3. That's minus 3. So if I move it to the right 3, there it is. Then this part right here, this minus 1, moves it down 1. Now notice it's the exact same function once it's been translated. Okay, so all this is a translation of the parent function. Now the reason why they matched up nicely was because my a value is 1 and my parent function has an a value of 1. So really cool. All right, so now let's look here at function g. So we have a lot of stuff going on here. We now have a negative. We now have a 2. So this is going to flip it. It's going to reflect it, and it's going to be opening down. And then that 2, since it's a bigger number, bigger than 1, it's going to make the parabola more narrow. Okay, and then we are translating to the left 2, and we're translating up 5. Okay, so we know because of that negative, we know it's opening down, and we know it's going to be narrow because of that 2. Okay, so the vertex, nice and easy, opposite, same. So that's going to be negative 2, 5. There it is right here. AOS, remember the AOS goes right through the vertex. It's going to be this line right here, right through the vertex, which is at negative 2, or just the x value of the vertex. Okay, the AOS is always the x value of the vertex. There's my AOS. Remember, that's an invisible line. Okay, it's not part of the graph. We just use it to help us graph. So 2 points. So here we are at negative 2. So I want to choose an x value that's close to negative 2. So I'm probably going to choose negative 1 and 0, just because those are easier numbers. I could choose negative 3 and negative 4, but those are bigger numbers. I'm going to get the same numbers. I'm going to get the same output. I'm going to get the same y values for each set. So I can either choose these 2, or I can choose these 2. I'm going to choose these 2. Okay, so first one is negative 1. I'm going to take negative 1. I'm going to plug it in. Plug it in right there for x. Okay, so I get negative 1 plus 2, which is 1. 1 squared is 1. Sorry, moving ahead. 1 squared is 1. Remember, you got to use the order of operations. It says parentheses first, then exponents, then multiply, then add or subtract. Okay, so 1 squared is 1. Negative 2 times 1 is negative 2, and negative 2 plus 5 is 3. And again, if you just put this right here exactly the way it is in Desmos, it will give you that number. Okay, so we've got the point, or the coordinate, negative 1, 1, 2, 3. That represents a point. And notice how it's going down. We want it to go down because our a value is negative. Okay, so my next x value that's close to negative 2 is 0. So that should be an easier one. So I'm going to plug in 0 into my function. So I do parentheses first. I get 2. Exponent, 2 squared is 4. Multiply here, I get negative 8. Negative 8 plus 5 is negative 3. So my y value for 0 is 0, comma, negative 3. So here it's 1, 2, 3. So there's 0, negative 3. Now let's use the AOS as a reflection. So if it's 1 unit away on the right side, we need another point 1 unit away on the left side. That's what this says right there. It says reflect each point across the AOS. So there's that one. There's 2 units away on this side, so it's going to be 2 units away on this side. And then notice if we connect the dots, we have a parabola that's opening down, and that's narrow. Okay, and again, if you don't feel like you can do this, you can always just put this section right here, just this part, into Desmos, and it will give you your value of negative 3. It's your y value given the x value of 0. Okay. All right, so I want you guys pause the video and try filling this out and graphing it. Okay, so you can circle things, fill in the vertex, the AOS, 2 other points, use the AOS to reflect, and so forth. Okay, pause it and do that. My A value is positive, so I know it opens up. My A value is 2, so I know it's bigger than 1, which means that it's going to be narrow. Okay, the vertex is, remember, opposite of h, comma, k. So it's going to be negative 1, comma, negative 4. My AOS, so here we go, negative 1, comma, negative 4. My AOS goes right through it. So that's negative 1, or just the x value of the vertex. Let's pick a couple points. So I'm at negative 1 now. I'm at negative 1, so I'm going to choose an x value of 0 and an x value of 1. See what I get. Okay, so I'm trying the x value of 0 first. I'm going to plug that into my function to see what my y value is. Order of operations, square it. 2 times 1 is 2. 2 minus 4 is negative 2. So I have a point 0, comma, negative 2 right there. Boom. So I had my vertex at negative 1. Then I plugged in 0. Now I'm going to plug in this point right here, which is, or this x value, which is 1, to see what my y value is. 1 plus 1 is 2. 2 squared is 4. 4 times 2 is 8, and then 8 minus 4 is 4, so I get 1, comma, 4. So 1, 1, 2, 3, 4. Now let's reflect across the AOS. So if I have a 0.1 unit to the right of the AOS, I need another 0.1 unit to the left of the AOS. This one is 2 units away, so I'm going to go 2 units away and put a point there, because remember, it's a mirror, symmetric. So there we have a narrow parabola that opens up. And notice how I label it. That was h of x, so I label it h of x. Right, it says right there h of x, so I label that that's h of x. Okay? So you guys can work on your assignment problems. Okay, so hopefully you enjoyed the video. Don't forget to like and subscribe.